Good morning and welcome to this postgraduate video course on advanced hydrology. In the last class, we looked at the new concept of synthetic unit hydrograph, in which we looked at the Snyder's synthetic unit hydrograph, which is based on the hydrograph characteristics. Today, we will start with a slightly different topic, which is very useful in practice or in the practical usage. For example, let us say we have a unit hydrograph of certain duration available to us, let us say a 3 hours duration, but we want to find out the direct runoff hydrograph response from the catchment which is subjected to a rainfall event which is of a different duration, all right. For example, 6 hours or 4 hours or 7 hours, all right. So, in that case, how we can get that direct runoff hydrograph response, all right. What we can do is, once we have a unit hydrograph, we can convert its duration, or we can find the unit hydrograph of a different duration. So, what we will do today is, we will look at a couple of methods of finding a unit hydrograph of different duration given a particular duration, all right. So, we will look at two cases. In the first case, the desired duration is the integer multiple of the given duration, all right. So, let me see here, what we are going to study today is UH of different durations, okay. And in this we will look at or first see the case 1, which corresponds to the case when the desired duration is integer multiple of the given duration, okay. That is to say, if your duration of the given unit hydrograph, or let us say the given duration is d hours, all right, and then you want to find out a unit hydrograph of a duration which is n times d hours, where n is an integer, okay. So, this is case 1 in which n is an integer, all right. Later on we will look at case 2 in which n will or can be a fraction, all right. It could be a real number, for example, 2.3, 1.2 and so on, okay. So, as always, what we will do is we will look at a step by step procedure, and then we will take up an example which will demonstrate how we can carry out these steps, okay. All right. So, let us look at the procedure first. What we do is we develop n columns, all right, of your d hour duration unit hydrograph, okay, which is lagged by d hours, okay. What do we mean by this step is that, let us say we have the unit hydrograph given to us, all right. So, we have the time base, at the certain interval we have the values of the unit hydrograph of d hour duration. Now, we want to find out the n times d hour duration unit hydrograph, all right. So, and let us say for example, the value of n is 3. Now, what we are saying in step 1 is we develop n columns of this d hour duration, that is n is equal to 3. So, we develop 3 columns, all right. So, we just have time versus the unit hydrograph, and then we lag it by d hours once and lag it by d hours once more, all right. So, that we will have a total of 3 columns, but the lagging will be done n minus 1 times or 2 times for n is equal to 3, okay. So, this step will be more clear when we take up the example. The next step is find the DRH due to n different d-hour unit hydrographs. Okay. What are we saying is that we find the composite or compound response in terms of direct runoff hydrograph, that is due to all of these n different unit hydrographs, all right, which are generated by back to back rainfalls of 1 centimeter each. All right. How can we do that? Well, we just sum these up. All right. So, we can say that sum them up. Okay. So, which principle we are using here? This is the method of or principle of superposition. All right. Okay. The next step is we say that this D is the DRH due to what? Due to how much rainfall? N centimeters of effective rainfall. Is this clear? We have one unit hydrograph resulting from 1 centimeter of rainfall. Then we legged it by d hours. The second column is also due to 1 centimeter of rainfall. The third column is also due to the 1 centimeter of rainfall. So, if you are summing these three up, the resulting direct runoff hydrograph is due to 3 centimeter of rainfall. All right. So, similarly, when value of n is other than 3 or any other value, we say that in general the sum or the composite direct runoff hydrograph which we get is due to n centimeter of rainfall. All right. And how about the time base? And it has a time base of, I am going to use prime here to define the modified time base, which will be the time base of your original unit hydrograph plus n minus 1 times d. Okay. You can verify that. Now, we have a direct runoff hydrograph with us, which is produced by n centimeter of rainfall, all right, and this n centimeter of rainfall occurs in how much duration? For n is equal to 3, we have n times d or 3 times d. Let us say d was 3 hours, and if n is equal to 3, this rainfall is occurring in 3 plus 3 plus 3, 9 hours. All right. So, we have a DRH which results from 3 centimeter of rainfall, which occurs uniformly over the whole catchment in 9 hours. All right. How do we find the unit hydrograph now? We use the principle of proportionality, right. So, we divide this direct runoff hydrograph by the total rainfall, which is 3 centimeters in this particular case. All right. So, then we say the final step is divide the ordinates of this DRH by n, which is actually representing the n centimeter of effective rainfall, to get your UH of how much? N times d hour duration. Okay. So, it is a very simple method, and actually it is called method of superposition. I think I forgot to mention that. So, let me do that here. This is called method of superposition. Okay. In which all we are doing is we are using the principles of linear theory, which are method of superposition or the principle of superposition, and also we are using the principle of proportionality, both of them. All right. So, what I am going to do next is I will take up an example, all right, which will demonstrate these steps. All right. So, let us look at that now. It goes like this: the ordinates of a flow hydrograph from a catchment of area 796 square kilometers resulting from a 1 hour storm at 1 hour interval. Were obtained to be or were found as these numbers. So, these are the data given to us in terms of the flow hydrograph ordinates. And the last one is 34, and all of these numbers that are given to us are in the units meter cube per second. Okay. What we have to do is determine the ordinates of a two-hour unit hydrograph from the same catchment. Assume constant base flow. Of your 34 meter cube per second. Okay. So, this is the problem in which we are given that the flow hydrograph ordinates resulting from a 1 hour rainfall, all right, which are given at 1 hour time interval, all right. So, all these ordinates are at 1 hour each, and then the duration of the rainfall is also 1 hour. Okay. So, we have 1 hour unit, we have to first find out the 1 hour unit hydrograph, and then we have to determine the 2 hour unit hydrograph, all right. How do we find the 1 hour unit hydrograph? Well, we first subtract the base flow, find the DRH, we find the total rainfall or effective rainfall which produces this, all right. How can we do that? We can do that by estimating the area under the curve, all right. We know the area of the catchment, drainage area of the catchment, we can find out the total volume, divide the volume by the area, that will give us the effective rainfall depth. Okay. So, what I am going to do is then I will give you some steps in a tabular form. Let us go to the next page and arrange the data in a tabular form. So, you have the time in hours, which will go from 0, 1, 2, 3, 4, 5, 6, 7 all the way to 12. Okay. So, these are the times which are given to us as 1 hour interval, all right. The total flow is given to us in meter cube per second. Okay. This is the data which I had just written. So, you have 34, 48, 98, 203, 815, 1100 and so on. I am just copying all this data which were given to us. (65), 47 and 34 is at the end of the 12th hour. Now, what we do is we find out the DRH for this 1 hour storm. How do we do that? Well, we subtract the base flow, all right. And what is the base flow? It is given to us as 34 meter cube per second, right. So, all we do is we calculate the next column by subtracting 34 from this second column, all right. If you did that, you will have 0, 14, 64, 169, 781, 1066, 1216. You can verify all these numbers. I am writing them quickly. We have seen one example which actually does this. Okay. So, I am not spending too much time on this, and the last one will be 0 because we are subtracting 34 from this column. Okay. All right. So, what we have now is a direct runoff hydrograph, all right, which is resulting from certain amount of effective rainfall. All right. Now, we want to find out the volume. All right. How do we do that? We just sum this column up. All right. Sum up all of these. Okay. If you sum them, you will get 4422. All right. And then the effective rainfall depth would be equal to what? Well, it will be 4422. This is meter cube per second, right? We multiply this by the number of seconds in an hour, which is 3600 seconds, all right, times 1 hour divided by hour. Okay. And then we divide this whole thing by the area of the catchment, which is 796 square kilometers. We need to convert it into square meters. So, you multiply by 10 to the power 6, this is square meter. All right. You take care of the units, all right, and then you multiply this whole thing by 100 centimeters in a meter. Okay. So, this will come out to be approximately 2.0 centimeters. Okay. So, this whole runoff hydrograph ordinates they result from 2 centimeter of rainfall. All right. Now, I have a DRH which results from 2 centimeter of rainfall. How do I find the unit hydrograph? I use the principle of proportionality, divide the ordinates by 2. All right. So, that will give me 1 hour UH, okay, in meter cube per second. How do I find that? I divide the previous column by 2, that is all. So, you will have 0, 07, 32, 85, 391, 533, 608, 326, 147, 62, 16, 07, 00. Okay. So, what I have obtained is the 1 hour unit hydrograph given the data, and this is the same procedure we had seen in the last class for a similar example. What we have to do is, now we have to develop n columns. What is the value of n here? N is equal to 2, because from 1 hour we have to find out 2 hour unit hydrograph. All right. So, we have to develop 2 columns and one of them is this one. So, we need to develop one more column which will be what? Which will be lagged by d hours. All right. And what is d? D is 1 hour here, okay, which is the duration of the effective rainfall. Okay. So, you have lagged d hour UH, all right. This is also in meter cube per second. All right. So, when you lag it, you can just put a dash at the initial one and then just copy this whole thing, this whole column, all right, you just shift it. So, this is called lagging. So, you have 0, 07, 32, 85, 391, 533, 608, 326, 147, 62, 16, 07, and then the last one will be 00, and it will go up to 13th hour. Okay. This guy will be at 13th hour. All right. So, if I go back to my procedure which I had given to you, you look here, we have to develop the n columns of d hour duration. This is the first step. Okay. That is what we have done. All right. The next step is what? Find the DRH due to n d hour UH. How? By summing them up. All right. So, that is the next step. So, what you do is you have these two n, that is 2 d hour unit hydrograph, you sum them up, all right, corresponding ordinates, that will be your total DRH due to, it will be due to 2 centimeter of ER. Okay. which occurs back to back. All right. So, this column plus this column. All right. So, basically what you have is this plus this, that goes here, this plus this goes here, and so on. Okay. If you did that, what you are going to get is 0, 0, 7, 39, 117, 476, 924, 1141, 934, 473, 209, 78, 2307 and 00. All right. So, you have obtained a direct runoff hydrograph which results from 2 centimeters of rainfall occurring in 2 hours now. All right. So, how do you find the unit hydrograph? Just divide this by n, and n is equal to 2. So, these ordinates you divide by 2, that will give you 2 hour unit hydrograph in meter cube per second. Okay. So, if you did that, so what I am doing is you just divide by 2, all right, all these numbers divide by 2 and so on. So, you will have 0, it will be 4, do not worry about the rounding off. Okay. This is I am taking the whole numbers, 238, 462, 571, 467, 237 and so on. Okay. All right. So, this is your answer for 2 hour unit hydrograph given 1 hour of unit hydrograph by using the method of superposition, okay, in which we looked at the method step by step, and then we have seen how we can implement that method. Okay. All right, let us move on. Now, what I am going to do is let us look at the second method, which is applicable for the case when n is a fraction. Okay. And we are going to use what is called the S curve method for this. We have seen what is an S curve. All right. We will briefly revisit or look at what is this theoretically and how we can actually calculate it with the help of an example. And once we have the S curve, we can find out unit hydrograph, or we can convert the duration of any unit hydrograph of any duration to any other duration. Okay. So, this is the major advantage of having this S curve. Okay. So, let us look at what we are trying to do here. Okay. A S curve hydrograph is one that results from a catchment when a continuous effective rainfall at an intensity of 1 by delta T centimeters per hour, okay, is applied on that catchment, that is for an infinite period. We have seen that earlier. Okay. All right. How can we find this? We can use equation 7.2.4, which we had seen earlier, okay, which is this actually, which is for your unit pulse response function. All right. What is that? H of t is nothing but 1 over delta t of your g t minus g of your t minus delta t. Remember this relation, we had derived this earlier. So, let me number this as 7.8.1. all right. This is a relationship between what and what? H is what? H is the unit pulse response function, and G is what? It is the unit step response function. Okay. So, it is a relationship between these two. Using this we can find out what is called your S hydrograph, okay, as per this definition which we have just stated here. Okay. Now, you can find out the unit pulse response function due to another rainfall event which starts delta t hours later and which has the same type of input, 1 by delta t centimeters per hour occurring after delta t hours, all right. What will that be? That will be h of t minus delta t, and you can put t minus delta t in place of t in this equation, right. So, if you do that, you will have g of t minus delta t minus g of t minus 2 delta t. Okay. This is 782. Okay. Similarly, you can keep on writing the response from another rainfall which occurs 2 times delta t hours later. So, it would be t minus 2 delta t minus g of t minus 3 delta t, this is 783, okay, and so on for infinite number of times, all right. What is an S curve? S curve is summation of all of these, that is what we are saying, okay. So, it results from an intensity which is continuously occurring, all right. So, if you did that and if you sum these up, what do you get? You will get, summing these, let me write it here, summing these equations, what we are going to get is your g of t is nothing but delta t of your h t plus h t minus delta t plus h t minus 2 delta t and so on, okay, where g is your unit step response function at any time or the S hydrograph, all right. So, theoretically it is given by the summation of the ordinates of your unit hydrograph, all right, which are separated by delta t hours or the d hour duration, all right. If you want to look at it graphically, it is equivalent to saying this in the same manner. This is your time ordinate and this is your, let us say, q or the hydrograph ordinate. This is your rainfall input, this is occurring for infinite period. So, this is your continuous rainfall, all right. What is this duration? This is delta t, right, and what is this intensity? We have defined already 1 over delta t, okay. So, the intensity is 1 over delta t which occurs for delta t duration. So, that what is the total amount of rainfall for within this duration? 1 by delta t multiplied by delta t, that is 1 centimeter, all right. That is your definition of unit hydrograph. So, basically what we have is the unit hydrographs resulting from these 1 centimeter of rainfall occurring back to back for delta t durations. That will be, let us say, something like this. These are your unit hydrographs. Continuing indefinitely, all right. This is your h t, this is next one is your h t minus delta t, next one is h t minus 2 delta t and so on, all right. So, if you are going to sum these up, these ordinates, you will get a response which will look like this, okay, and this is what is called your S curve, okay. All right. So, this is the concept of the S curve theoretically as well as graphically, okay. Now, what I am going to do is I will give you the procedure for finding out the unit hydrograph of a t hour duration, all right, given the unit hydrograph of d hour duration, and d and t can be any numbers, all right, and we will take the help of the S curve, all right. So, let me give you this, the procedure. Given a d hour UH, find your t hour UH. Okay. Let me go to the next page for that. Okay. All right, the procedure goes like this. Given the data, first what we do is we find the S curve, okay, and I have just explained you graphically, all right, and theoretically how we can do that, and I am going to take up an example to demonstrate that. Okay. So, we first find the S curve ordinates or S hydrograph, that is first step number 1, and in the second step we lag the S curve by what? Any ideas? By t hours, okay, by t hours. Okay. Let me try to give to you what we are trying to do here. Okay. So, this is your time domain and this is your q domain. Okay. What you have is this first rainfall, okay. This is intensity is equal to 1 by d centimeters per hour. It is occurring starting at t is equal to 0, all right, and this results in this S curve, okay, and let us call this S A, all right. So, what we are doing is we first step is find the S curve ordinates. So, this is your S curve ordinate or the first S curve. In the second step we are saying lag the S curve by t hours, all right. So, you have this S curve, we lag it by t hours, let us say this is your t, okay. There is no relation between d and t, all right. So, we lag it by t hours, what we are going to get is same response which is delayed by t hours, and then ultimately it will reach the equilibrium discharge, all right. It is going to meet the same discharge, and I am going to call this S of B, let us say, okay. All right, and what is the input from which this is resulting? Well, this is starting here, this one, and this is the rainfall which is occurring continuously, and this is also I is equal to 1 by d centimeter per hour occurring infinitely. Okay. So, you have the first S curve that results from an intensity of 1 by d centimeter per hour which occurs infinitely. The second one is the another S curve which is lagged by t hours, that occurs by the same pattern of input or intensity of rainfall, but that rainfall pattern occurs t hours later. Okay. All right. So, in the next step what you do is find the difference between the two S curves, all right, that is S A minus S B. Okay. So, what you do is you subtract S B from S 1, all right. In a tabular form you will subtract the data like we had done in the previous example. So, this is your S A minus S B, all right. So, we can find this S A minus S B. What is this S A minus S B? This represents what? The S A minus S B represents a direct runoff hydrograph, all right, which results from what kind of input? If you look here, what we are saying is the first curve S A results from this whole input which is continuing indefinitely, right, whereas the second one is resulting from this input. And when you subtract these two, what is the resulting direct runoff hydrograph? That is resulting from which input? It is basically this input. Do you see that? Right? It is resulting from an input of intensity 1 by d centimeters per hour occurring for how much duration? T hour. What is this? T hour. Do you see that? Okay. You have the two curves. We are using the method of superposition. We are subtracting the two. All right. We know the input patterns of the two. So, we know the input which causes this S A minus S B, which is the direct runoff hydrograph resulting from this rainfall. Okay. Now, if we have understood this, then the last step would be very easy. Divide the difference, that is your S A minus S B, to get T hour U H. Divide the difference by what? Okay. What is the amount of rainfall which is causing this S A minus S B? The amount of rainfall is what? Intensity is what? Intensity is 1 by d centimeters per hour, and it is occurring for how much? This T hour duration, right. So, multiplied by T hour. So, how much is the rainfall then? It is T by d centimeters. Do you see that? All right. So, the S A minus S B is the direct runoff hydrograph response from the catchment that results from T by d centimeter of rainfall. Okay. Once I have known that, I can find out by proportionality your T hour U H is going to be equal to what? It is S A minus S B, those DRH ordinates divided by T minus D. Okay. This is as simple as that. Okay. So, this way we see that how we can determine the S curve ordinate number 1, and then once we have the S curve, we can use the method of superposition and the method of proportionality, because they are all linear systems, to determine or to convert the duration of one hydrograph from the to the different one, which is a fraction of the other. Okay. So, this is going to be given, this is an example I am looking at, given a 4-hour unit hydrograph ordinates. All right, these are given to us, and we have to determine a 12-hour unit hydrograph ordinate using S curve. Okay. You see that in this case n is equal to actually integer, but we are going to demonstrate the use of S curve method for the conversion of the duration of this unit hydrograph. All right. I am not copying the data here, I will do that directly on the next page. So, what we have is, we are given the data of time versus what? Ordinates of a 4-hour unit hydrograph. So, that is what is given to me. This is in meter cube per second. All right. So, let us say this is your column 1, this is your column 2, and these are given at 4-hour intervals. Does not have to be, they could be at any other interval. All right. (40, 44, 48, 52, etc. Okay. And the ordinates that are given to us are 0, 20, 80, 130, 150, 130, 90, 52, 27, 15, 5 and 0. Okay. So, these are the data that are given to us. Okay. So, first what we have to do actually is, we have to first calculate the S hydrograph or S curve. All right. theoretically we have seen what it is and what is the equation, but in a tabular form we will use a slight trick, okay, so that our computations are simplified. Right. So, I am going to give that method how we can calculate this S hydrograph quickly using only 2 columns. Otherwise, you have to write these unit hydrograph ordinates infinite, all right, many number of times, and then keep summing them up. Okay. We do not want to do that. Of course, if we did that, we can get the same answer, all right, but we will use a very compact method. All right. So, what we do is we develop 2 columns, and in developing only these 2 columns, we will get the S curve. Okay. So, the next one is what is called the S curve addition column, all right, and this is also in meter cube per second. Let us call it column number 3, and the next column is going to be your S curve ordinate directly, all right, and this is going to be in meter cube per second, and this is your column 4, which we say is equal to column 2 plus column 3. Okay. All right. So, what we do is the first entry we just throw here. Okay. So, this is your ordinate, what you are doing is you are transferring it here, that we can do that easily, all right, and then what we do is we transfer this ordinate to the next column or the previous column in the next entry, all right. So, you can transfer this 0 in third column just after 20. Okay. Then what you do is you do the column 2 plus 3, that is this one plus this one, and this will go here. So, what is it? This is going to be 20. Is it clear? Let me go over it again. The first ordinate of your unit hydrograph, which is what? At 0, let us say it is 0. We just transfer it to the S curve ordinate, all right. So, the first data in the S curve ordinate is same as the first one in the unit hydrograph. Okay. Then what you do is we transfer this number, let me see this arrow, actually it should reflect here, we are transferring it here, okay, to the previous column in the as the next entry. You transfer this number here, and then the next entries, all right, at 4 hour will be the sum of next ordinate plus the S curve addition column. Okay. All right. So, then we have 20, and then this 20 we are going to transfer to the next, which is at the end of 8 hours, all right, which is, let me say 20 here. What is going to be the next entry here? It is 80 plus 20, which is how much? 100. Okay. And we keep on repeating this process, all right. This way, using only these 2 columns, all right, one is the S curve addition column, other is your directly S curve ordinate, all right. It will this procedure which we are doing essentially amounts to the same thing as if you are lagging a 4-hour unit hydrograph infinitely, that is you are doing so many numbers and then keep on adding them, all right. It has the same effect. Okay. So, let me quickly then do this. You will have 100, and then let me put 100 here, and then you will have 230 here, all right. Then you have 230 here, and you will have 380 here, then 380 comes down here, then you sum this, you will have 510 here. If 510 here, then this will be 600, and then 600 and plus 52 is going to be 652, and so on. Okay. $699 plus 0 is going to be $699, and we can keep on doing this actually, and then you will get the same number 699. That is to say, the S curve hydrograph will saturate at what is called the equilibrium discharge or a constant discharge, which is 699 in this case, all right. So, these are your S curve ordinates, this whole column, okay. And how do we calculate? It should be very clear. All right, now we are going to apply these steps basically, this one, to calculate a T hour unit hydrograph, and T is 12 hour in this particular case. All right. So, what are these? Find the S curve ordinates, which we have done. Lag this S curve by capital T hours, and T is equal to 12. So, we will lag it by 12 hours, then we will find the difference S A minus S B, and we will divide that by T by D. All right. So, that is as simple as that. Let me show you that. So, the next column is going to be your S curve lagged by how much? T hours, which is 12 hours in this case. It could be 11, it could be 10, it could be anything. All right. Okay. 12 hours means what? Let me first say that this is your column number 5. So, you will have dash in the first 3 entries. All right, 0, 4 and 8. So, the first entry is going to be at what? At 12 hour. Okay. So, because we are lagging it by 12 hours. How do we do that? Well, we just transfer all these ordinates here, we are just lagging it. So, you can cut and paste all this if you are doing it in Excel. All right. Okay. So, let me do that. You will have at 12 hour it will be 0, then you have 20, 100, 230 and so on, 380, 510, 600, 652. These may not correspond to the times I have put here. All right, but you understand which entry corresponds to which time. Okay, there should not be any confusion. 694 and 699. Okay. So, now I have got this is your S A, and what is this? The other one, this column is S B. All right, and then the next one is going to be column 4 minus column 5, which is nothing but your S A minus S B. Okay. If you did that, what you are going to get is this 0, 20, 100, 230, 360, 410, 370, 272. You can verify these numbers. You know these steps and how I am doing it. Okay. I am just subtracting these previous 2 columns. Okay. Five and 0. Okay. So, now you have got column number 6, which is the difference of 4 and 5. All right. Finally, you will have column 6 divided by what? Divided by T by D. T is 12, D is 4. Okay. So, you divide this column by 3 to obtain what? This is going to be your 12 hour unit hydrograph, which is the desired one. In this particular case, it happens to be an integer multiple, but it does not have to be for S curve method. Okay. So, the next step is simply dividing the last column by 3. Okay. That will give you the desired answer. All right. So, let me say that this is your column number 7, the last column, which is 12 hour unit hydrograph ordinates. Okay. So, this is going to be these numbers. You can verify these very easily. And so on. Okay, 1.7 and 0.0 is the last one. Okay, so this is your final answer. Okay, which is the 12 hour unit hydrograph. Okay. All right. So, what we have done today is we have looked at two methods of determining the unit hydrograph of different duration. Given a d hour UH, we are finding n times d hour unit hydrograph, where n was an integer in the first case. All right. We use what is called the method of superposition. All right. And if the n is not an integer or it is a fraction, then we can use the S curve, and we have seen a very compact method of how to determine or how to find the S curve, and then how we can use this S curve technique by lagging and by using the principle of proportionality and superposition to find out the unit hydrograph of a different duration. Okay. So, with that actually we come to the end of this particular chapter on unit hydrograph, in which we have seen comprehensively the linear systems theory, the definition of the unit hydrograph, its basic assumptions. Then we have seen these three basic functions which are needed, all right, in applying these linear systems theory. These were unit impulse response function, which we said is equivalent to the instantaneous unit hydrograph. The second one we said was the unit step response function, which was nothing but the S curve, and the third function we defined was the unit pulse response function, which is nothing but the unit hydrograph. All right. And then we looked at 4 different methods of derivation of the unit hydrograph for a simple storm and the complex storm, and then we also looked at the multi-storm analysis, in which we can combine the data from different storms and then get a composite unit hydrograph. All right. And today, as I summarized, we looked at the conversion of the duration of the unit hydrograph. So, with that we come to the completion of this, what I should say is the deterministic hydrology or the conceptual methods, at least partly, and then in the next lecture we are going to start a new chapter in which we will move on to the stochastic hydrology, wherein we will look at some probability and statistical concepts and how they are implemented in hydrology. Thank you.